Okay, so for any test, you just want to realize that what chapter you're studying, and that's the most likely things to come up. Now, unfortunately for this chapter, it's going to include previous chapters, so you have to remember how to do substitution and how to figure out where two lines meet. But most of the chapter is going to be about midpoint, and actually she'll focus more on what you've learned lately, which is the length of the line segment and actually the combination of these things, and the formula for a circle. And she'll still throw in some of the old stuff, but it'll be mostly combo puzzles. You also have to remember what the median is, what the bisector is, what the chord is, what a tangent is, how to find a perpendicular line slope. So you have to reciprocal and change sign, and possibly things like area of a triangle, which is half times the base times the height. But overall, it's going to be coming down to the formula. So when you come across a question, I want you to instantly just say, okay, they mentioned the word midpoint, write down the formula. So this is a great example. So this is the test review practice test. The midpoint, as soon as I see midpoint, I'm going to say, okay, you know what? I'm going to write down the midpoint formula, and it's just going to help me focus on the questions at hand. So I'm going to go back over here and just grab it and come back and just go, okay, midpoint formula, here we go. So also remember that sometimes they're going to give you the midpoint, and each of these can be calculated individually. Like if they give me an unknown x, and I know the x of the midpoint, I can figure it out just by connecting it. I don't need to worry about the y. Same with information. But if you fill out the formula, it should lead the way. So here they give you endpoints, which means it goes in here. The endpoints are here. And if once you put it in there and you do it, I'm not going to do the simple ones, you'll discover it's probably C. Okay, you can almost see it right away. 1 plus minus 3 is minus 1. 5 plus minus 3 averaged out divided by 2 is 1. And then here the length of a line segment, right? So as soon as you see that, you should go ahead and just say, okay, I'm going to write down my length of my line segment just so that I have a clarity of what I'm doing. So here it is, length of a line. It's essentially y2 minus y1 squared, x2 minus x1 squared. And I say the length of the line segment with endpoints. So they're giving me the endpoints. So I could just do either one I want. And I actually might find using the minus 4 is going to be easier. So I'm going to put the minus 4, minus 2. And then I'm going to say, okay, I got to do it in the same order. 1 minus minus 5. 1 minus minus 5. Because the minus over here has to do with the formula. It always stays in there. And the minus is associated with the number, change the result. So 1 minus minus 5 is 6 squared. And minus 1 minus 2 is minus 6. So you can see they're both the same. 6 squared here is 36. And 6 squared here is 36. And when I add them together, it's square root of 72. And I can see the choices right there. An equation for the circle with a center of 0, 0. So hopefully she hasn't changed. There is a formula for a center of a circle that doesn't have 0, 0. But right away, as soon as I see that, what am I going to pull up? I'm going to pull up my formula for a circle. Here we go. And I'm just going to put it down. And I'm going to say, okay, radius 4. Okay, radius 4. That means where I see radius, I'm just going to put in this 4. And immediately I can see that that comes out to 16. So I can even rewrite that as equals to 16. Leave them both there, so just a reminder of one or the other. And then what's the equation going to be? Well, we kind of just did it right there. So these are like baby step ones, obviously. And then we just continue through the test, determine the midpoint of each segment. So when it's visual like this, if she gives you visual ones like this, just look at it instead and see if you can visibly. Sometimes the diagonal ones you're not going to be able to see it, but the horizontal ones you're going to be able to clearly see it. 1, 2, 1, 2. What's that midpoint? That is 1, 4. And just to check it out, 3 plus minus 1 is 2, divided by 2 is 1, and 4 plus 4, or sorry, yeah, 4 plus 4 divided by 2 is 4, so it's always going to come out 4 when it's the same number, and you can see that works. But visibly, the vertical ones are easy to see. Now, sometimes it's tricky. That has 3 squares, that has 3 squares, and then there's 1 square, so it's going to be right in the middle. which means my y value is going to be negative 0.5, and my x value is simply going to be minus 3. But you can do it algebraically. Minus 4 plus 3 is minus 1. Minus 1 divided by half is minus 0.5. And then minus 3 plus minus 3 divided by 2 is still minus 3. And you'll see for verticals, the x doesn't change, and for horizontals, the y's don't change. But when you come to this one, you're going to instead have to figure out just the x, y using this formula. So let's take a horizontal like this and try to grab all its points. And we're going to erase all the other points. And by the way, what are we doing here? We're trying to find a length we're trying to find a midpoint formula. So we have to use the midpoint formula, right? So let's pull up the midpoint formula. And we're going to grab it. And just always keep your formulas handy. And you know what? I'm gonna keep the whole thing like this, and I'm gonna just make it a bit cleaner, like that. And then I'm just gonna get rid of the ones that I don't care about anymore, like that and like that. So focusing on this one, pick a y. So you got 1 minus minus 6. Oh, it's a midpoint. 1 plus minus 6. 1 plus minus 6 plus a minus. It's 1 minus 6. It's minus 5 divided by 2 is minus 2.5. You're pretty good at these. And then for the x values, I got 3 plus minus 2, which is 1. And 1 divided by 2 is 0.5. Now, I can keep that in fractions. So it's going to be a half, comma, negative 5. Let's make sure I got the right thing here. Might as well do it again. So I got 1 plus minus 6. That's minus 5. So I got minus 5 over 2 as the y value. And 1 over 2 as the x value. And I can either put that like that or decimals. And I think your teacher will accept. This is just 5 divided by 2. And keep the minus. And it's simply plugging it into the formula, which you're pretty good at. And then just looking at this last one, I'll just slide the x's in. And the y's in. I got minus 1, minus 2, plus minus 5. So I got a plus minus 5 there, which becomes minus 5. So I got minus 7 for my x value. Minus 7 over 2. Let's just leave it as a fraction. And then for my x values here, I got 4 plus 6. 4 plus 6 is 10. 10 divided by 2 is 5. So I get 5 comma minus 7.5, which is minus 3.5. And if you look carefully on your charts, you should be able to confirm it pretty visually. Minus 5 and about minus 3.5 or 2.5 do I have? Yeah, I might have done the error there. Might have taken the wrong one. Minus 2, minus 7. So it's minus 7 over 2, which is minus 3.5, which makes sense. It's right there. Visually, you can come close, but I would not use visuals for diagonals. I just quickly put it in the midpoint formula. Okay, next one. Oh, that's Chapter 2 review, so we're doing the test here instead. Write an equation for each circle. So the secret here is to say, okay, all I need to do is find the radius, because the radius squared will be the circle. So quickly, just looking at this red inner circle first, let's say like there, I can quickly see that the radius here from 0 to 4. So I can just say x squared is equal plus y squared is equal to 4 squared. And I just rewrite that as 16. And that's the formula, that circle. And then I do it for this other outer one. It goes to 6. I do the same thing. It's equal to 6 squared. But you resolve that. So it's equal to 36. Formulas of circles that go through origin are super easy. Moving onwards. Rachel makes the following statement. And this is going to be interesting. And I wish I had a good Desmos open for this because it would help to see it. This statement is not true. And we'll have a look. Rachel makes the following statement. Since point A is the same distance from both B and C, it must be the midpoint. And I'll show you why bisectors exist. So here's point A, or sorry, here's point B, here's point C. And she says, since A is right in the middle, or same distance, it must be right in the middle, which is true. A can be a midpoint. But let me show you another situation where A can be the same distance from B or C. This situation, A is the same distance here and the same distance there. And actually, I can place A anywhere along the bisector. That's the answer to this question. I can put it anywhere along this green line that goes on forever, up and down. And A can quite easily fit. Why isn't that? Oh, is it not? I don't know what's going on there. So we'll try it again. We'll just say A like that. Oh, it's got a weird. Go all the way to the top. I don't know what's going on with this thing. Try times. There we go. Let's just try that. A. Bizarre. What's going on with this? Okay, so I'm going to try to copy this all and then just close this sheet because it's suddenly gone wonky. Did I just screw up? Yeah, I did. Oh well. So to go back to it, I'll just start fresh. She's not correct, and I'll show you why the bisectors exist. So if I take B and C and find the exact middle bisector, which is a line that cuts through its midpoint, but perpendicular, like this, roughly. And then I take the letter A. I can place this letter anywhere along this green point, and it's going to be the same distance from A and B. That's why the bisector is in existence. And remember this, because it's useful for figuring out puzzles. No matter where I drop it on this green line, if I drop A, it's going to be the same distance from B or C, because that's what the bisector does. It produces a triangle that's always going to be the same distance, no matter where I put it. So that's the answer to that, and it's also going to help you in the next questions. Jason lives exactly halfway between his primary school and his other school. Now be careful, because these questions, they're always going to want you to answer more than one thing. So be careful. And again, I'm just having technical difficulties. Yeah. So I got to pull this all the way down. There, let's try this again. There we go. And crop and zoom. So Jason lives exactly halfway between the primary school. Here's where Jason lives. Here's his schools. So he's at the midpoint. But notice they mentioned kilometers, so it's probably going to be units. How far apart are the schools? So that means you need to do a length formula. Determine the coordinates of Jason's home. Jason's home is in the midpoint. So that's a midpoint formula. What other locations could be equidistant from the two schools? Explain your reasoning. Well, in that case, you would have to find the bisector that we just went over that cuts, and I can't just draw it. I have to kind of figure out the slope and explain that, you know, probably there, all those spots along the green line will be the same distance. Whatever spot I pick on the green line on the bisector will be the same distance from those schools. So let's start with how far apart are these schools? Okay, well, the line formula says I have to take x squared, x minus x1, x2 minus x1 squared. So that's 10 squared. 10 squared is 100. Plus y2 minus y1, 8 minus 3 is 5, 5 squared. Boom. So that's going to be 25. 100 plus 25 is 125. And then I have to take the square root. Now, 144 squared is 12, and 121 square rooted is 11. So this is slightly more than 11. So don't forget to take the square root, and don't forget to say kilometers, because that's what your teacher will take points on. But if she wants it in decimals, you would take the square root and probably just round it up to 2. So there you go, 11.18. 11.18 is the distance, kilometers, don't lose a mark, is the distance between schools. And then determine the coordinates of Jason's home. Well, that's a midpoint. So now I have to take the midpoint of all those points, and I'll just undo everything. And I'll just say, okay, well, midpoint for x is 14 plus 4 divided by 2. And write down your midpoint formula. So that's 28, or 18 rather, divided by 2, which is 9. And we'll be able to conform. By the way, you could probably just read it on the graph. And then the other one, 9, is 8 plus 3 divided by 2. So we get 11 divided by 2. So we're talking about 9, comma 5.5. And if I look quickly, sure enough, there's 9 and 5.5. And then the tough part is figuring out this perpendicular. Now you could guesstimate and just kind of guess, but there looks like you could answer any point along the bisector, but if they're looking for a specific point, we'd have to find the slope of this, find the slope of that, and then find the formula. And I don't think that's what they're looking for. Determine an equation that represents all locations. Oh yeah, so that is what they're looking for. So first we have to find the slope of this to find the perpendicular slope of that. Slope is y2 minus y1, so we wish we'd kept it, which was 8 minus 3, which is 5. And the other one was 14 minus 4, which is 10. So we can see the slope of the blue line is 1 over 2. That means the perpendicular and reciprocal, the reciprocal negative, or change sign, is negative 2. That means the slope of the green line is negative 2. Now, we also have Jason's main point, and that's the only point I can use. Jason's main point, where he's located, is at this point. So now I have to put this into the formula, mx plus b, to figure out the formula for the green line. Fortunately, I have a point. 5.5 is equal to negative 2. What was x? 9. Plus b. So I got negative 18. It's fine to work for in decimals in this situation. Negative 18. But, you know, if you're not going to, well, I'll show you a way in a second. So then I add 18 to both sides. I get b is equal to this, which is 23.5. Now, if you wanted to put that over 2, by the way, this is what b is, so now I've got to rewrite the formula. Y is equal to negative 2x plus 23.5, which means I could put in any x value now and figure out a y value that fits on this line. For instance, if I pick something that's visible, let's pick 10. If I choose x is equal to 10, then negative 2 times 10 is negative 20, plus 43, yeah, plus 23.5 becomes 3.5. So I can see that 10 comma 3.5 will also be equidistant from the school, which is right about, so I drew my green line wrong, it's right about there. And that square there will be the same distance to either school, even though my drawing's kind of wonky. Let's try that again. 10 kind of 0.35. Now I'd also want to go back and make sure I did all that equation properly. The point is not to get the right numbers here, it's to show you how to figure out. So how far apart are the schools? Length formula. Where's Jason's coordinates? Midpoint, but you could just see it on the graph as well. What other locations are equidistant to the school? Any point on the bisector. Determine an equation for the bisector. We got to figure out the slope here, which is 5 over 10, which is a half. And then once I figure out that, I can do the reciprocal and change the sign. So that means negative 2 is the slope of the green line. And then I have to use Jason's point very carefully, 9 comma, and I believe it was 5.5, to figure out where he is located. So minus 18 plus 20, yeah, 23.5 is B. And then I got to put it all together. Y is equal to negative 2x plus 23.5. And once I have that formula, I can plug in any x value and determine any y value on that green line that will be equidistant to that house. Now, I might have made a mistake on the 10 coordinates, minus 20 plus 23. It should still be 3.5. It's just that doesn't quite look equidistant, but that just might be the distortion of this drawing. Okay. Just remember, all we're always going to probably be doing is using those main formulas. So number 8, and I'll keep 9 up as well. Plot the triangle. Like I said, always try to draw it. And always try to put them in order of y. So that's the biggest y. That's the tallest. That's middle. And that's lowest. And then after you've done that, sort them in x. So this is the furthest most left x, and this is the furthest right most x. And suddenly you have a rough idea of what this triangle looks like. Give yourself some space to draw, because they're always going to ask some questions. And always read ahead on the question. So I'm going to join these points. AC, CB. And then we can't classify this triangle until we know more about it. Determine the lengths of the sides. So that's clearly, I'm going to use the length formula here, length formula here, length formula here, 3 times. Once I have the length formula, I'll be able to classify the triangle. Now be careful. When they say classify the triangle, it probably does have an easy classification. How the heck do I do this? I need to find the height of any one of these areas. And you might say bisector, or you might say median. The height is very tricky to do. If you imagine a 90-degree line here, that is going to create the height, right? But to do that, let's see, what's the fastest way to figure out the height of the triangle? I think there's probably a faster formula than I'm describing to do the height. Let me quickly, so bisector isn't the way to go because the bisector's in the middle and it won't work. I know that's going to be 90 and that's going to be 90. So it's going to be 90 to the slope of this line and going through that point, which is a kind of a pain in the ass because then I'd have to find the length of that. So it would be a point that's 90 degrees to this and going through this point will reveal the height. Yikes. There's probably an easier formula, and you should ask your teacher because you can see that she wants you to find the area, which is half times base times height. We'll see if there's an easier way to figuring out the height. It's definitely easier when they're all in the same plane because then the height's really easy to see. But we'll do our best. So let's just start in the order. Determine the lengths. So what's the length formula? It's y2. Let's start with this, and it would have helped if I colored them each a little differently, right? And if you find yourself wasting too much time on a formula, move on to the other questions. Move on to the other questions. So I'm going to make this red, and I'm going to make this blue. And so I'm going to now focus on green length AC. I'm not going to do them all, and I'm not going to classify it. AC is equal to y2 minus y1. So I got 5 minus 1, which is 4 squared. So 4 to the power of 2. And then it's 0 minus minus 2, which is 2. And it's 2 squared plus 2 squared. So I've got 16 plus 4. I got 20. But I got to take the square root of that. So that means AC is the square root of 20. And you could just put it, yeah, just leave it there. But it's essentially just there. And then for this one, y2 minus y1 is minus 1 minus 1, which is minus 2. So I got minus 2 squared. And then 2 minus minus 2, which is 4. So I got 4 squared. 2 squared, so I got to add them. 2 minus 2 squared is 4. 4 squared is 16. Add them together, 20. So I can see that we've got a little disproportionate drawing because it would appear that AB is also the square root of 20. So it's the same thing. And then finally here, 5 minus minus 1 is 6. I got 6 squared. And 0 minus 2 is minus 2 squared. It's the only one that's different, I think. 36 plus 4, I get the square root of 40. Which means, oh, there we go. That'll make my life a lot easier. Which means I'm talking about isosceles, or sorry, what's the one that has 2 sides? You can look it up. 2 sides are equal. So this is square root of 20. And this is square root of 40. Now, I want you to be careful. If I flip this thing around, if I rotated this thing around, and I drew a length down here that's square root of 40, right? And both these sides are the same up here. Here, let's make them red. And here. Well, that means that this square root of 40 is indeed the middle point because these are both square root of 20. Square root of 20, which means since they're the same sides, they're the same angle here. And that means right in the middle of square root of 20 will be the height. Now, if I was to divide this bottom line up, it means that into 2 equal parts because it'll also cut right down to the bottom of the middle. That's what 2 equal sides does. It means this side here of this blue line is square root of 20. And this side here of the blue line is square root of 20, which means I can technically figure out the height. Now, actually, that should, I think I got one wrong because there's no way this can be the same length as half of that. So let me just go back and look at this. 5 minus 1 is 6 squared. 36. And, oh yeah, square root of 40 is not, half of it is not square root of 20. That's my problem. So yeah, it's very confusing. I'm sure there's an easier way of figuring out area. To go back to this, it means half the triangle over here looks like this, where I have square root of 20 or square root of 40 divided by 2 over here. And half the thing over here looks like this, and it has another one that's equal on this side, which means this height can be determined. This height is equal to square root of 20 minus square root of 40 over 2 squared using the Pythagoras Theorem, because this squared plus this squared is going to be equal to that. So that minus that squared minus that squared will be equal to that. Well, 20 squared is 20. 40 over 2 squared is 40 over 4, because they both get squared. So that would be minus 10. So you get a height of 10. Now that I know that's a height of 10, very convoluted question, I know. I know that the square root of 40 times the height of 10 divided by 2, so times 5. 5 times square root of 40 is the area of this triangle. I believe there might be a faster way of doing it. I'm very surprised. I don't doubt that your teacher's going to add a question like this. That's the area of the triangle. But it would be super hard for me to explain very quickly how to find an accurate height. Another method would be, again, find the slope between these two lines. The slope between these two lines is minus 2 over minus 4, so the slope is a half. The perpendicular slope here is negative 2, which actually doesn't make sense. So I'll try this again. Minus 1 is minus 1, minus 2. 2 minus, yeah, so it's actually negative a half is this one, which means the perpendicular slope here is plus 2, which means I'd have to find the spot that it intersects to find this distance. Still a pain in the butt. To find that red line that leads through here, I'd have to use that very annoying formula, and I'd have to use 5 is equal to 2, so B is equal to 5. So this is the formula of that line. Then I'd have to see where it intersects with this line. Big pain in the butt. Much easier to realize that when it's a is it isosceles has two sides, that this side will cut right in half here and use your Pythagoras theorem. But that's a brutal question. Plot the triangle. So always draw. So sorry for that going on and on and on and on. Plot the triangle. Again, do the same thing. Which one's the highest y value? This one. Which one's the lowest y value? This one. So this one's in between. Then sort their x values. This one's the lowest x value, and this one's the highest x value, which means I can draw a line like this, and I'm going to do different colored lines this time, like this, and finally like this. And then they want me to draw the median from vertex R. So that I'm going to do that in a black line. So the median from vertex R will cut through here into this blue line at the blue line's midpoint. Then it'll say determine an equation for this median. So they want an equation for this black line. To do that, we need to know the midpoint, we need to find the slope, and we need to find B. So we start with the midpoint. The midpoint between these 2 points uses these 2 points. It's 3 plus minus 5, which is minus 2 divided by 2, which is minus 1. 4 plus 2 divided by 2, which is 3. So that means the midpoint up here is minus 1 comma 3. Just use your midpoint formula to figure it out. Now I need to figure out the slope between of that black line, which is between R and my M here. figure out the slope, I take y, 2 minus 3 up above, and x, 2, 1 minus 1 up above. And I get 2 down here, and minus 4 minus 3 is minus 7. Very cruel thing that they've done. So I've got minus 7 over 2 is the slope for that black line. And to figure out a point, I can use either of those points. So writing down the slope of this black line, I got minus 7 over 2x plus b. And the b line I'm going to use is the easier one. I'm going to use up above 3. So what's minus 7 over 2 times minus 1 for x? It becomes plus 7 over 2. Plus b, rewritten so that we can see it more visually. It's like this, 7 over 2. I've got to multiply everything by 2 to get rid of that. So when I multiply this by 2, it disappears. But this by 2 becomes 6. So you can see I'm just left with 7 here. I subtract the 7 from both sides. I get 6 minus 7 is equal to 2b. That's minus 1. And when I divide both sides by 2, I discover that b is equal to negative 1 over 2. So now I have a formula for the segment line, and it's technically this, minus 7 over 2 plus 1 over 2, I think it was. And now that's the equation for the medium. Is this medium also the altitude for this triangle? So the altitude would be the height. I think, actually, let me look up altitude for triangle. I think it's the height. And we'll just go to visuals. Yeah, I believe it's the purpose. Well, essentially, does it form right triangles and reach the height of the base? Well, no, we'd have to determine that this is right angles. If this black line is right angles, because we know it reaches the peak, if it's right angles to blue, then yes. We know the slope of this is that. So all we have to do is see if it's a right angle to Q and P. Because if it's right angle, since we know it's reaching the point, if it's right angle, it is indeed the height or altitude of this triangle. So we just need to determine if the slope of PQ is the reciprocal and opposite sign. In other words, is the slope of PQ 2, 7? Well, let's look at PQ. 4 minus 2 is 2. And 3 minus 5 is 8. Now, I might have done a calculation error, because that's damn close to that. So I would check my calculations error, and I would even draw it on graph paper to get a much better idea here. So I got minus 3, comma 1 as my median point. I've got minus 5, comma 2 is another point. And keep in mind you're only going to be doing it, quickly on a graph paper. And I got 1 minus 4 as another point. And then when I look at them a little bit more closely, I might be able to see if it looks more like right angles. You know what? It does. I'm willing to bet I got the slope of this one wrong. Minus 4 minus 3 is minus 7. 1 minus 2 is 2. Minus 7 over 2. 4 minus 2 is 2. 3 minus 5 is 8. No, it's close, but it's not the altitude. So let's try that this way. I don't think that's the right angle either, so hang on. 4 minus 2 is 2. So it'd be 8 of, so it'd be 2. I think it'd just be 2, wouldn't it? And then x minus 1, y minus 3. I don't know why I'm not getting that. 4, 2, 2 over 8, so it'll be minus 4. There we go. And as you can see, that's right angles to the red line and just misses. Kind of a cruel question. Essentially, altitudes that would reach that corner would be right angled to that line. And it needs knowledge of triangles to answer that question. Okay. Determine the coordinates of the other endpoints for the diameter shown. Okay, sometimes you can just look at it and do it, right? When it's graphed like this, it saves calculations. But sometimes they'll want you to verify with a calculation if it's not really clear. If we look very closely, it's very clear. That's minus 3, and that is 5. So we can almost save ourselves time and go minus 3, comma 5. And just put it there. Of course, there's going to be more questions. Does any other point in the circle have the x-coordinate of 3? Yeah, of course. Straight up to 3, right there. And guess what? It's going to be 3, comma 5. Notice they're all, you're also going to have a minus 3 down here, right there, minus 3, minus 5. They're all going to share similar coordinates. Determine the equation for the circle. Okay, well, going back, 1, 2, 3, 4, 5, 6. Y squared, or x squared, plus y squared is equal to 6 squared, the radius, which means this is the formula. Explain how you can use the equation of the circle to verify your answer to part B. Well, if this goes in here, and these are all accurate, left side will equal right side. So again, 3 squared, 9, 5 squared, 25, 25 plus 9, 36. Left side equals right side. And it's clear no matter what number I use, once they get squared, they become the same 36. Determine the coordinates of 4 more points in the circle. Well, if you really want to cheat on that, you can see right here, there's a good one right there. 5, comma, here's how you do really fast on that one. 5, 3, which means I'm going to have a 5, comma 3 here, a 5, comma negative 3 here. Notice there's a connection with this one. There's going to be a negative 5, comma negative 3 here, and there's going to be a negative 5 right here at this one, negative 5, comma 3. And you can almost just take those things and swap them, and you'll find another spot that matches. That's another trick. You see how it was 5, 3, and I found 3, 5? You can just swap these numbers, and they will be on the circle every time. So, for instance, right, there's a good one. 2, comma 5.5 means 5.5, comma 2 will be on here too. So there's 5.5, comma 2 right there. So, you know, that's because when you do x squared plus y squared, if you're swapping your x's and your y's, you're still going to get the same sum. So another good, oh, you know what? I got the formula of the circle wrong. That's not quite 6, is it? That's not quite 6. I think they just misdrew it because these are clearly, so if I do x squared plus y squared, that clearly comes out to 36, which is 6. So I don't think they've drawn this quite nicely. Because if this is a point on the circle, I can put it into the formula 3 squared plus minus 5 squared. And it becomes 9 plus 25. Oh, you know what? I'm stupid. 34. So I should have just put it into the formula to come up with that. Yeah, stupid. Sorry about that. So be careful using the numbers, and I should have looked more closely. I should have used this in the formula to discover 9 plus 25 is 34. And you can see, you know, like I'm racing through this to try to show you how to do it. Determine the coordinates of midpoints G and H. Well, midpoints, you just use that. Verify that GH is parallel to DE. Well, I would then have to find the slope between GH and compare it to the slope of this. Show that GH is exactly the half length. I would have to find the length of that. Okay. And just, you know, pull up your formulas each time. This is what, just racing through this is probably really good to say, can I answer that? Do I know how to answer that? And then spot the ones that you can't. So determine the coordinates of GH. So 10 plus, I think that's 6. So it's going to be 8 for Y and 3. So 3, 8 right there. So I'm going to just mark it down. 3, 8. I did a quick midpoint. What about H? Well, okay, so 4 plus 8, half. 12, so it's going to be 6. And then 10 plus minus 2 is 8, 4, 6 comma 4. But notice I could have just found that from the graph. Now I need to find the slope of that. So 4 minus 8. I can even do the other way. 8 minus 4, 4. 3 minus 6 minus 3. So that means the slope of that one is minus 4 over 3. And that means if this one is the same slope, so I'm going to take 6 minus minus 2, that's 8. And then 2 minus 8 minus 6. And that can be simplified to minus 4 over 3. Since they have the same slope, they are the same. Now what about length? Well, you got to do the same, y2 minus y1, but you got to square it this time. Whoops, I want to keep those coordinates on there. So notice I could have just read the coordinates. So we're going to pull out the line length formula, like that. We're going to put it in, and we're going to do one by one. So we're going to do this y2. So I got 8 minus 4, so that's going to be 4 squared. And I've got 3 minus 6, so that's minus 3 squared, which means I'm going to get 9 plus 16, which is the square root of 25. So this is 5 long. So that's 5 long. Then when I look at the other ones, I'm going to take 6 minus minus 2, that's 8. So I get 8 squared for y2 minus whatever. And then I'm going to take 2 minus 8, so I get minus 6 squared here. So minus 6 squared here is 36, 8, 64, 100, square root is 10. So I can see this is 10 long, and it's exactly half. This short one's exactly half. 12. How do I answer 12? Show that the triangle with vertices here is a right triangle. So I have to show that one of these lines, I have to show that these lines are perpendicular. Verify that the median from the right angle to the hypotenuse is half as long as the hypotenuse. Okay, so we have to go for that. So always help yourself and draw it out. Helps if you have graph paper too. But we're just going to rough it. Okay, I strongly recommend graph paper. And then do this. I'm going to say which line is far to the right. Looks like that one. Which one is, and it doesn't matter what order you do this, which one's far to the left, that one. Which one's in the middle, that one. And then do the y. Or y first and then whatever. That's the highest y and that's the lowest y. So it looks like we're doing like this. So now it's clear to me that I have to prove that this slope is perpendicular to that slope. And don't trust your drawing unless you're using graph paper. So very quickly, if I look at this slope, it's minus 5 minus minus 3, which is minus 2 divided by 0. I should have done the other way, actually. Minus 3 minus minus 5 is 2. Minus 4 minus 0 is minus 4. So I get simplified 1 over minus 1 over 2. So that means this slope is minus 1 over 2. And always write it down, WV slope. Now, I've got to prove that this slope is perpendicular, and I'm going to use this one. So 3 minus minus 5 is 8, and 4 minus 0 is 4, and that's positive 2. And it's clear that minus a half is the reciprocal and change sign. So yes, that is a right angle triangle. Then you move on to the other thing. You might want to mark down the slopes just in case. So that means the slope of VU is 2. And then verify that the median from the right angle, so that's the right angle, to the hypotenuse is half as long as the hypotenuse. Okay, so that means I have to prove that this red line is half as long as the hypotenuse. Now, the hypotenuse very quickly is y2 minus y1. So 3 minus 3 is 6 squared, plus 4 minus 4 is 8 squared. And I can tell you right now that's going to be 64 plus 36 square root. So the hypotenuse is going to be 10 long. 10 long. I got to prove that this is 5 long. I need to know its midpoint. So the midpoint, 3 plus minus 3, that's going to be 0 on the y. And then 4 plus, it's going to be 0, 0. So we're going to go through 0, 0. So now I got to figure out the length of this midpoint. So I'm going to use this point because the zeros are easy to use. Minus 5 minus 0 squared, so 25. And 0 minus 0 squared. Notice that we're going to be on the axis here. So plus 0. So that means that it's going to be square root of 25, which is 5. So all you do is you find the midpoint, and then you use the length formula to prove that this is 5 after finding out the length of that. So that means you can, yes, the median is half as long. Find an equation for the circle that passes through the vertices. So the circle has to go through all 3 vertices. Now try to remember this midpoint is 0, 0. Because that might help us. Because probably we're going to have a circle that fits through all of them, right? So like that. Not quite. Something like that. Notice that it appears that my 0, 0 is damn close to the circle. Now I also want you to notice that this point over here is kind of opposite this point over here. And right away I can say, well, you know what? I bet you the circle is 5 radius. And I bet you it's x squared plus y squared. It's simply because these points are opposite and they haven't given you circles that don't go through origin. And it's also noticeable that that reached origin. So how would I figure it out? It would mean that this, for these points, these 2 points to be on the circle, that would have to be a diameter. No, not necessarily. There's just so much indication. I don't know how you prove it, though. I think you have to find out a formula where all these points would appear on a circle. So that means you take this left one, okay, and you put it in the circle formula. So minus 4 squared plus minus 3 squared is 16 plus 9 is 25. So for this to work, for this to be on a circle, it would have to be x squared plus y squared is equal to 25, right? Which means the radius would have to be 5. So there's the big hint there. Then we go ahead and do it on this one to see if this one is also going to be 25. Because that's the only way they can all be on the point. And sure enough, when I do this one, 4 squared plus 3 squared, 25 square root is 5. It works. Then when this one's, sure enough, minus 5 squared plus 0 squared is square root of 25, which is radius 5. So they all fit into this circle. So you just take one point, figure out what it comes to, and see if they all come to that. I just plug it in and see. So it would be like this. And then I put in the formula for my circle. Sure enough, look at that. They all hit that point. There's a whole bunch of points you can come up with too. Any variation of this will be on there. And the swap will be on there too. 3, 4. Anything that's squared and adds up to 25. And that's actually an interesting thing. So if I have I don't know if I can find a nice clean point other than the ones we used. But any point you find, you can swap them. It'll also be on the circle. So minus 4.9, 0.995 if I swap them. There we go. Is also going to be on the circle. Kind of a pointless thing. Okay, let's just leave that like that in case I need it. 12, that was 12. If I go to 13, Scott, oh, so then she's going to throw one of these on there. Scott, Arif, and Diane run a small delivery company. Let's just go through it. They use licensed two-way radios with a 20-kilometer range, so that's a hint. Scott is at their office, so let's just put office and Scott. Okay, which they have marked as the origin, so that's good to know. Office is at 0, 0. The grid lines on their map are spaced 1 kilometer apart, so your teacher's going to want units. Arif is dropped off at a package of -6, 18, or -8, 16, which is going to be somewhere up here, left and up. And Diane is making a pickup at 4, 20, which is going to be right and way up, higher than that. This one's going to be, yeah, Scott's going to be closer to this one, but this one's going to be lower like that. Scott, if I put Scott closer to where he is, it's something like that. The grid lines are, yeah. Draw a diagram to represent the reception range for the radio of the office. So that's a circle. So if Scott can reach a 20-kilometer range, that's a 20-kilometer range like that all the way around, because wherever Scott points, it's going to reach 20. We just got to see if they're within radio range. Now, right away, seeing that 20, they're out of radio range, because these numbers could never add up to the 20 that we're looking for. This one, maybe. So then, if I'm going to put Scott as a radio, and his range of his radio is 20, I would write it like this, is equal to 20 squared. This is Scott's range on his radio. And if I write that 20 squared in a number, it's x squared is equal to 400. So that means if those spots on the, where they are, if I put them into a formula, yeah, sorry, like that, something like that, there we go. If I put these into a formula and they come up as less than 400, they're within Scott's circle. If they come out as exactly 400, they're right on the circle. And if they come up as more than 400, as this one certainly will, because 20 squared plus 4 squared is going to be more than 20 squared, then he's outside of radio range. Find an equation that describes the boundary of this area. I just did for the radio range area. Are Arif and both within range? Is justify your answer. Okay, 8 squared is 64. 16 squared, I'll have to look it up. I don't have 16 squared off the top of my head. 256. When I add them up, I think she's right on the boundary. Oh, she's well within the boundary. 320. Which means that any number that comes smaller than the 400 is going to be within the circle. To give you a better idea of that, so for 20 squared, there's the circle. Now I'm going to put her at her spot, which was -8 times 16. So yeah, she's within the circle. Now he or the other person was at 5, 20, I believe. 4, 20. Anything with 20. If he was at 0, 20, he'd be right on the circle. Right? But anything that's above that, even 1, even though you can't quite see it, he's outside the circle. That's because there's no way I could square and add up these numbers to equal 20 squared. So seeing as he's here, it's quite obvious he's outside the circle. But all I would do is square his number, 16, plus 20 squared, 400, and find the square root of 416. But it's quite obvious right away that the square root of 416 is going to be bigger than the square root of 400, which is 20. So he's quite obviously outside. Are they within range of each other? So the big question is, if these two people had a radio, are they 20 kilometers apart? Good question. What formula would you use to find out how far apart they are? The length of a line. So y2 minus y1, 4 squared, plus x1, 4 minus 8, 12 squared, they're very definitely within the range. So that's 16 plus, that comes to 16 plus 144, which is 160. And if I take the square root of 160, you'll clearly see that they're only 12.6 kilometers apart. Now she will want answers, and you'll have to use kilometers if she wants distances between people. But notice that this is a convoluted question because you have to understand how a radio works. A radio works with a person in the center. If the radio had a 20-kilometer distance, it's going to be 20 kilometers. It's going to be 20 kilometers from the center of where that person is all the way around. Now, if you look close enough, I'm just going to get closer and just circle and circle. You see a circle sort of should appear. As if I were able to circle this perfectly, you would see a circle go around. I wonder if I can create that here. I wonder if that would work. It's a good question. I don't think I can, actually. I'll work on that to see if I can spin a circle around so fast you see a circle. But the point is, if his radio range is 20, it will form a circle. And you have to find if these are within the circle. If you put them in the formula, and what's 20 squared? So his radius is 20 squared, right? It's 400. So any number that I put, coordinate that I put in, if they come up more than 400, they're outside the circle. Less than 400, they're inside the circle. Exactly 400, they're on the circle. That's how all circles work. Achievement check. So you'd have to notice that they're opposite. So if you find their midpoint's going to be 0. You just have to find the distance between 0, 9, and 5. So 9 squared is 81. 5 squared is 25. So you get 106. So the radius of this circle is 10.3. So it's x squared plus y squared is equal to 106. If I add them together, minus 9 plus 5, oh, maybe not. Oh, it's circle centered at origin. Determine the midpoint C. Well, the midpoint C, if it's between chord AB, should be the center of the circle. Show that the right bisector of chord B passes through the center of the circle, which would have to. Give a different solution for C. That's a stupid question.